Another great application of a quantum internet is that it enables secure access to quantum computers in the cloud. So what does that mean? You can imagine that just like how classical computers were once rare and extremely expensive, early quantum computers are likely to be rare and extremely expensive. So let's imagine that quantum computers are available and you want to use them from the comfort of your own home or from the comfort of your own office. So you buy some time on this quantum computer in the cloud to perform your favorite calculation. And quantum computers promise to perform quite a few calculations much faster than the classical computer. For example, quantum computers are extremely good at factoring numbers. Now you might imagine that you want to use the big quantum computer far away to factor a number. And to do that, you actually send a message over the classical internet saying, "Can you please factor this number for me?" For example, you might say, "Please factor 15." And the quantum computer would send a message back saying, 15 is 5 times 3. Let's imagine, however, that you actually want to perform computations on sensitive data. For example, quantum computers are thought to be very good at simulating molecules and performing calculations in chemistry. So you might imagine that maybe you want to perform a computation involving a molecule that is proprietary or under investigation. Or maybe you want to use the big quantum computer to perform a computation that involves your own DNA. Possibly you would be somewhat more hesitant to actually tell the computer what your DNA is in order to use its computing power.
How can quantum solve this?
Secure quantum computation in the cloud solves this problem. And to achieve this, we need a quantum internet. Of course, if you needed a quantum computer at home in order to access the big quantum computer in the cloud, if you want to think historically, the quantum mainframe far away, that would defeat the purpose. You already have a quantum computer at home, so why not use it yourself? So what you really want is that you can have a cheap, tiny quantum computer, a quantum terminal at home, which is an extremely simple quantum device. And you can use this simple quantum device to talk to the big quantum mainframe far away. But in order to do this securely, you want to send qubits to that big mainframe. So you can imagine that you only have a tiny quantum terminal which can only prepare and measure single qubits, and you're going to use a quantum internet to send qubits that encode the secure computation to the quantum mainframe far away. Then the big quantum mainframe is going to perform the quantum computation for you. And it's going to return you messages from which you can learn the answer. It turns out that sophisticated protocols exist that allow you to use the quantum computer without revealing your input data, like your DNA, and even without revealing what you actually want to compute. So the quantum computer will not know whether you're trying to factor a number or whether you're trying to perform a computation on some piece of DNA. This is known as secure delegated quantum computing, or blind quantum computing, and it requires a quantum internet to transmit qubits from the quantum terminal to the quantum mainframe in the cloud.